Hi, Naveen. Today we are going to start law of conservation of energy and finish this unit completely. ඉතින් අද මේ කතන්දරේ ඉවරයක් කරලා දාන්න යනවා. We are going to finish this entire lesson, entire tube related to the very basic theories, everything going to over. But I have to tell you one more thing, that we have to do really good amount of questions. I'm planning to do that on the next week. Right? I'm planning to do that on the next week. Okay. So today we are just going to complete the entire set of law of conservation of energy. So before doing that one, I want to do you to do something. So we did certain question. I told you that is the gateway for the understanding of law of conservation of energy. Right? ඒකෙන් තමයි ඔක්කොම තේරුම් යන්නේ. So everybody, we did this question in the last week, but it's better for us to do it again. The question is in the page number 8, the third one. The third one we did in the last week. It doesn't matter. Do it one more time. Do it one more time, right? We did it, yes. We have to redo it. And after, I will explain you the law of conservation of energy one by one to you. Understand? So students, start to do the question number 3 in page number 8. Question number 3 in page number 8. Q3 in page 8. Do it. Come on, do it. Question number 3 in page number 8. Come on. Everybody, start to do the question number 3 in the page number 8. I'm pretty sure the printing shop owner has a big beef on you. See, this is how the standard of quality of your tube they have given. The same printing company. Gave this quality for 2006. Same company. I don't know what's wrong with them. See? Okay, keep doing. Question number 3 in the page number 8. Until then, I will draw the path. Question 3 in the page number 8. Okay. Okay. You have all the details given here. You can just try it again. The same question. There is a reason. You will understand why it is. So, do it. Did you finish it? You had enough time. Let me know whether you finished it or not. Hello, students. Okay. For the first one. Hello, Lamai. Can you hear me? Can you hear me? Yeah. Okay. Have a look at what is the potential energy so at the moment of when a hot shot, all right, releases a 5 kilogram shot. The shot is like 3 meters above the ground and traveling at 15 meters per second. It reached the maximum height of 8 meters above the ground and then falls onto ground. Air resistance is negligible. Use G as 10. Okay. What is the potential energy of the shot as it left the hand relative to the ground? Okay, have a good look at here, Amai. So that's why I made a certain stage here, because it is unreal thing to be 3 meters. Now it is asking about the potential energy as it released the hand. Have a good look at it. E equals to mgh. mgh. So mass is like 5 kilogram, 10, and the height is like 3 meters. 150 joule is the amount of energy staying. Yeah, that is the amount of energy in the object as potential energy. Right. Make a What was the kinetic energy of the shot as it left the hand? All right. Now I want to find out the amount of kinetic energy in the hand. Right. Let's find out the amount of kinetic energy for the part 2b. This is a half mv square. Half into mass is like 5. V is going to be 15 by 15. 5 times 15 times 15 is going to be 225. 225 times 5 is going to be 1125. Then you have divided by 2, that means 662.5. You will reach the kinetic energy, right? Now have a good look at this one. Has the kinetic energy of this much, 662.5. Here it is like 150. Now in the question asking about what was the total energy of the shot as it left the hand. What is the total energy? Initially he had, when he was releasing it. Sorry, not 600. Yes, it is 500. Good observation. 500. Very good. It's 500. Yes. When it is releasing, it was just above. Yeah. It changed it. Yeah. 150 joule. Here's 562. Sorry. 562. Now it is going to be what? Total energy. Our total energy is the collection of potential as well as kinetic energy altogether. Kinetic energy altogether. Okay. Right. Have a look at it. E total is going to be EP plus EK. Right. Let's find out. E total is equals to 150 plus 562.5. Altogether total is 812.5 joule. 812.5 joule. That's great. Now the next thing it is, what was the total energy as it reached to the maximum height? It is like this. Your mom just give you like some food as a parcel to you to eat and some money. The money is what you can buy. Sorry. Oh, now see ya pretty good. Sorry, 700. Yes. Yeah, 700. Yes. It is like your mom gives you some food for you to eat. It's as a parcel, but parcel and she gives you some money. Money is the potential energy. You can buy something and you can convert it. Okay, have a good look at it. Now you just have like altogether your food you have. It has some monetary value as well as real money. The next question asking is, when it is at the peak, that means you have spent some of the money your mom gave you, but you have bought. Like imagine you buy some kind of like a mega bottle to you to drink. You have that mega bottle, the food with you, and the remaining money with you. It's like that. At this point, the potential energy is there as well as kinetic energy is there. Now look at now what's going to happen. The total is the same total it had here, but it's 712.5 is the total. That should be the same total here, 712.5. You have to have this basic idea. Right. Have a good look at it. In the next one, what was the potential energy of the shot at maximum height? In the maximum height, you know the total should be 712.5. Now the potential energy you can find out using this MGH, 5 kilogram, the 10, and the height is 8. It is about 400 joule. And now you know the amount of energy you have with, that is 400 joule. In the next one, it is like, what is the kinetic energy at the shot at maximum level? You know that total is 712.5. 400 already used up. What is the remaining as the kinetic energy? Kinetic energy is 712.5 minus 400. Kinetic energy will only be but 312.5. I think you can understand this very well. You keep using up, keep using up, keep using up. Here, see 400, 712.5 minus 400 and 312.5. Okay. In the next part, asking about what was the kinetic energy of the shot as it struck the ground. Okay, now let me check the potential energy in the ground. M is 5, G is 10, but the height is 0. Overall potential energy reaches to 0. Now asking about the kinetic energy. I will firstly show you mathematically. It shows like E total equals to EP plus EK. Right? Here only two changes. 712.5 is the total. The potential here in the bottom, no height, it is 0. Kinetic energy will automatically become the total because the potential energy completely loosened. It has completely converted to kinetic energy. Now you will get an idea. In the bottom, the kinetic energy is completely 712.5. Do you understand this completely now? මේ සෙට් එකම තේරුණාද දශමයක් ගන්න නැතුව? Yes, very good. Okay, now it is time for us to go for law of conservation of energy. If you want to, you can copy all these answers. I will only give you 1 minute for you to copy this down. Again, please. Okay, I will explain you one more time, no problem. Until just copy this. I will explain right from the beginning. Right. Did you copy? Yeah. I am just about to explain you that part. I'm just about to explain you that part. Yes. Okay. Have a really good look at and listen to me very well. Okay, have a good look at here. Here, when you lift something, haven't you seen the shortcut? They just turn like this and release. At the point of release, it is just above the ground. Now it is 3 meters above ground. So there is a 150 joule potential energy. We calculated it here. And what I'm going to do is, I'm going to throw this. Right? Throw means it has some kinetic energy. It is related to velocity, half mv square. Here like half into 5 into 15 into 50. Half is per half, m is just 5. And v is like 15. 15 square means I have to write it twice. 15 times 15 is going to be 225 multiplied by 5 is what? 1125. When you divide that by 2, it is 562.5 joule. I found that one too. Right? In the next question, it asks about what is the total energy? What do you have? You have potential energy, you have kinetic energy. When you join them together, you will get the total energy. What is the total energy here? Total is potential energy plus kinetic energy, 150 plus 562.5. The total is 712.5 joule. Okay? Right. Have a really good look at here now. Now at this moment, it has total energy of 712.5 joule. Now it reached to certain maximum height. In the maximum point, it has potential energy as well as some sort of kinetic energy. The easiest thing is that we can identify potential energy at here. How to find out mgh? EP equals to mgh. M is 5, G is 10, H is 8, altogether 400 joule. Got it? Right. If it is 400 joule, the total, we know that total is 712.5. Now imagine a situation where your mom gives you like food and all and some money. If you are not asking one of your friends for giving you some money, or if you are giving some money to your friend, or something happens like that, otherwise your potential of eating capacity because of your mom's food as well as your pocket money altogether has some value, right? That is the total power you have, buying power. No more than that, if unless you asking for someone's help. So the total energy is 712.5 at the top, altogether 712.5. Then I realized that the potential is just 400. So what is kinetic? So total is like here, see, potential plus kinetic. kinetic only is total minus the potential over here. Then it's going to be 312.5 joule. I hope you understand. They're running. Right. Have a good look at here now. At this moment, it is about 312.5. Now it is asking like, what is the kinetic energy? So our equation is what? Total equals to potential plus kinetic. Then for height is 0 on the ground level. EP equals to mgh. M is 5. G is 10. Height is 0. Altogether 0. When I substitute 0 to here, total is 712.5 equals to 0 plus kinetic energy. So kinetic energy is 712.5 joule. It is an obvious result, isn't that? ඕනම කෙනෙක්ට වඩකාලා තේරෙන දෙයක්. එහෙම නේද? ඔව් කියන්නේ. Now nailed it නේ. ඇති. Okay. Let me erase this one. Now I want to ask you some certain questions. ළමයිද පන්සල් එහෙම ගිහිල්ලා හොඳ නේද? කට්ටිය පන්සල් ගිහිල්ලා බණ භාවනා කරලා එහෙම එන්න ඇති නේ හොඳ ළමයි. In the bottom EP converter PK yes in the peak sir. Right? Yeah. I will explain you. Not only because of the potential, it had some kinetic at the initial two all together. Because energy we can add or subtract easily, right? The reason is energy is kind of a scalar quantity. If it is a scalar, we can add or subtract directly without considering directions. Understand? Okay, have a good look at. Now I want to ask you something. In the last Sunday, entire country just went blackout. නේ රුවි කටයි සනුලටයි ඇරෙන්න අපි හැමෝටම ඒක දැනුණා. We all felt that, right? We all live in Sri Lanka currently. So we felt, why? A monkey jumped onto Panadura subdivision. So he just made some kind of like short circuit condition. A transformer blasted. Altogether, whole energy system just went blackout. So the whole world is running on with power. What power? Energy resources. So in terms of energy resources, electricity is dominant. Electricity and like petrol and diesel, those things are right dominant. Why it is? Because we have a law called the law of conservation of energy. Using that, we can interconvert energy from one form to another. Before going for the law of conservation of energy, I would like to ask you one single question. Did you guys watch that 2-minute video of Spider-Man I sent you? අර Spider-Man movie එකේ පොඩි කැලලක් දැම්මනේ. අද lesson එක තනිකර තේරෙන්නේ ඒක කරොත්. How many of you watch? බලපු කට්ටිය ඩක් ගාලා yes කියලා message එකක් දාන්න. Drop me a message that if you watch it. Yeah, Tobey Maguire, one of my favorite actors. Nowadays, the Spider-Man is Tom Holland. I don't really like that guy. One reason is he's short. Other reason is he looks very immature. But he's a talented guy. Right. If you haven't watched that movie, at least you might have watched the clip I sent you. That is the base of this entire lesson. මේ මුළු lesson එකේම මුළු base එකම තියෙන්නේ මේකේ. Okay. Here. Okay. I told you energy can convert from one form to another. I would like to ask you, in Sri Lanka, electricity is very essential for us as well. We felt it in the last week and the yesterday and the day before yesterday. How many resources of energy we use for generating electricity? Can you name one? I will describe of that one form and how it is behaved. Just name one mode of generation of electricity in Sri Lanka. Just name one form. ඔයාලගේ උත්තර ඕනේ. මම දන්නවා මට කියාගෙන යන්න පුළුවන් එහෙම නෙමෙයි. One said hydropower. Okay, hydropower. Okay, word turbine means hydropower. Enough. Adi, don't answer. I am now going to describe about hydropower. In terms of hydropower, there is a dam. We build a certain dam by interrupting the way of water flow in a river. We just block actually, make a very big reservoir. Now, you may have seen in the last rainy season, in like 1 month ago, you could see many rivers, kind of like lakes, and all the very leading reservoirs were like overflowing. Then you could see it acts as if a certain waterfall. You think like that time there is a waterfall, and you connect a certain turbine and rotate. Is that how? No. That is the excess water. Right? So in a kind of like powerhouse, power plant, there is a tunnel. There is a tunnel from the bottom. That tunnel is like few kilometers long. That tunnel brings this water to lower level. And there is the so-called turbine. There is the so-called turbine and the generator. So-called turbine and the generator, right? Okay, how would we look at now? Now water begins to flow from here across here. Now, what is the type of energy it has in here? Tell me. What is the type of energy it has here? Yeah, what potential? Huh? What potential? We have to say specific name, because there are multiple potentials you will get to know soon. That potential is known as gravitational potential energy. Here it has the energy of GP, gravitational potential energy of water. When it runs through this type of slope to the bottom area, these reservoirs are made on top of like a mountainous area. When the mountains are like declining from the height like this, you can easily construct a powerhouse just below, somewhere below, right? Now the water has what energy? Kinetic energy. Water has its own kinetic energy. Now this water just rotate the turbine. So the turbine has its own kinetic energy now. The turbine is connected to the generator using a shaft like this. Right? It rotates automatically when this rotates. So now the generator rotates. As the generator rotates itself, it can produce, actually generate electricity. Electricity. And now it is electrical power. Electrical energy. So what is it? Gravitational potential energy, kinetic energy. What? Electrical energy. Now can you understand something? Energy can convert from one form to another form. So there are many more conversions are there. Sometimes there is a boy now, within few months, he is no longer a boy. Because of the modern technology. But thanks to Donald Trump, we can secure two genders now. Right? It's convertible from one form to another. So why sir? That means you are supporting them. You are supporting those people, those weird people. I never support. I am with Donald Trump. ලංකාවේ නම් පුළුවන් නම් ඡන්දේ දානවා. Okay. Gravitational potential energy. Then it converts to kinetic energy. Finally, this kinetic energy converts to electrical energy. That means energy can convert from one form to another form. If you want, you can convert to another form. No need to copy this. If you really like, only copy this very quickly. No, take a screenshot. Don't draw now. Take a screenshot if you only want. Or just watch the recording and do it. It's very simple. Okay. Now the next question I want to ask. What are the other type of power plants you may know? This is the hydropower plant. Then solar power. Okay, solar power. Good. I will explain you. It is a very simple thing. In a solar panel, there are very small things called solar cells. Solar cells are invisible. When you arrange solar cells together in series and parallel and make a very big collection of them, then we used to call solar panel. Solar cell is an invisible type of small thing. So visible actually is too small. So the solar cells collect together. So in a solar cell, when solar energy is light energy, radiation energy actually. Energy as radiation, it falls on the solar cell. In the solar cell, electrons begin to jump from one side to the other. In the last lesson of ours is the matter and radiation. In that part, we are going to learn about this. So now it directly converts, no intermediate effect like turning turbines and generators, no such scenario. It directly converts this solar energy to electricity. It is direct conversion. Okay. Have you ever tried to light up an LED bulb? කවදා හරි දවසක LED එකක් පත්තු කරලා තියෙනවා? Yourself. Just joining it by two wires. Yeah, you are correct. In the last three is like genetical mutation. But the first 3 to 4 guys are not due to genetic. Yeah. When you connect an LED to source of power, right? So this will begin to radiate light energy. Radiate light energy. Electricity, light. Here in the solar cell, the opposite. Very simple. Here, light energy converts to electricity. In an LED, electricity converts to light. So both of them are diode. This one is also a diode. This is a diode. This one is also a diode. Light emitting diode. That's why we used to call it as LED. Yeah. Okay. Right. Boy, it is a very long, controversial point. During a class, we can't discuss about them. One day, if we meet in physically due to some kind of activity or someone time after your A-level exams also, we can have a big debate about this. The thing you said. Okay. Right. Electricity converts to light. Here, light converts to electricity. Actually, if you arrange like 10 to 15 LEDs and join them in parallel connection and get via two wires and connect to one LED, you can keep the other LEDs on directly under sunlight and you can light up the one LED. That means it can also produce LEDs can also produce electricity, right? LED, because this can also run with the reverse process, but it is not how it is designed. So the energy production is very low here. The reversal process. If you provide electricity through this one, it can also do it, but not designed to accordingly. Right? Lime, because you can do it with the lime because it is a chemical reaction, not with the photo cell. Okay, somehow here in your case, like the lineman zinc and zinc plate and copper plate experiment, it is about chemical energy converting to electricity. Okay, now another thing. Can you name another way of production of electricity? One said like thermal. There are two ways of we use thermal energy in Sri Lanka. There are 3 or 4 other ways, but in Sri Lanka we only use 2 ways. Can you name one thermal energy? Hydrothermal? Ayyo, I'm asking about thermal. Hydrothermal, one. Fossil fuel, yeah, there are 2 ways of use of fossil fuel. One is diesel. If you have just go across Kalani River from Paliagoda to Totalanga, then when you just travel very close to Grand Pass side, you can see there is a very big power plant called Kalani located there. That is the diesel power plant. And when you travel from Katmai Expressway to Colombo, you can see a very big power plant that is located in Keralapidia in Vattala. That is also very kind of like very big diesel. So before explaining of all these, I would like to ask you one simple question. A car, a bus, a train, whatever, working with motor engines, they produce energy to run the vehicle as well as it produces its own electricity for lighting, to operate radios and stuff, and kind of like horn and all. It produces its own electricity too, and also to run AC. Why? There is the thing why it can generate its own electricity by rotating the engine. While it rotates the engine, there is a part called an alternator. That alternator rotates itself as well and produce electricity. Like in the same way, in thermal power station in diesel, they just run a big engine like a size of a house, and it's connected by a kind of like a generator. As the engine runs, the generator rotate and produce electricity. Now in all power stations are quite different. Quite different. Let me explain you. It is completely different from all of these. Have a look at. There is a thing called boiler. In the boiler, it can kind of like evaporate water and produce steam. So you could like hold here and just set fire on it. What happened? The coal burns. In Hindi, koila. Koila jala diya. It will produce superheated steam. We used to call superheated steam. S, right? SH3. So, see, superheated steam. HSS steam, superheated steam, has the kinetic energy. Here the thermal energy. Right? It is highly pressurized. When you keep a generator rotate, kind of like what is called turbine rotate, generator rotate, but it will produce electricity. Okay. Don't you see the reversal process take place in our homes? That means we use electricity to produce heat. Can you name one or two examples for that? What about the example like that? Electric oven. Very good. In the oven, if your elder sister or your mom just prepare like bake a cake, when they bake cake, they just operate the electricity kind of like oven and produce something delicious. If that is akka, very bad. If that is amma, very good. That's how it is. Electric iron. Then heater to prepare tea. Then is that all? How about rice cooker? It also produce. If you have a sister or someone, they may use kind of like hair dryers. A hair dryer we use. And normal bulb, it produces heat, but we are not using a bulb to get heat. But it produces, it is not the purpose though. Any electrical instrument just produce heat. Even the mobile phone get heat. Sometimes we can't put like this. It is too hot. Yeah, a stove, yes. Unlike room heaters in other countries during this time because it is the winter now. We can convert electrical energy to heat. Can't we just use electrical energy to here in the right here in this part? What happened? Potential energy was converted to kinetic energy in the generator. Don't we do the reverse process of that in our house? අපි ඒක reverse කරන්නේ නැද්ද? Can you tell me? Yeah, induction cooker ඔය එන්නේ හරි. Don't we reverse the process? Huh? Yes, what is it? What is it? No, I think. Oh, seriously? Yeah. Water pump. Electrical water pump. Abhi motor kiwada, motor is the only running machine. There is a pump separately connected. The motor rotates, it rotates the pump. It is like this type of turbine. So that one will run water upwards. So in house, what happened? There is a pump. This is the motor. We just drop it in the well. So the plumber just set this up in a water tank. So we do the reversal process of the dam and power station. Honey, if you have like grade 5 to 6 younger brother, he may have like a STEM kit in science class that he has to perform certain thing like producing kind of like electricity right? Here, he may just come up with certain small turbine and he connect it to a small motor and he just use a kind of like what LED and he show you අයියා මේ බලන්න මේක ටැප් කරලා බලපුවම වත් වෙනවා බල්බ් එක මම යකා නගිනවනේ ඒකට කියනවා අපෝ ඕකට අපි අවුරුදු 10කට විතර කලින් like that නේ he again make a mini hydro power plant. Yeah, yogurt spoon and reform, you have done it. Then can you understand? This energy can convert from one form to another. If we want that form to the previous form, again from that form to 2 and 4, it is like volleyball. Tennis. Right? We can, in every action, the amount of energy lose. Efficiency is not 100%. We have to talk about that part too. Okay, I hope you understood this. Right, you may get an idea how it converts from one form to another. Got it? There another? Now only I am coming to explain you. Now only I am coming to explain you the very basic of what? Now one day I am going to explain you the Spider-Man effect. Okay. Now only I am going to explain you that Spider-Man effect. Okay. Now each of you have to just respond me. What did you see in the Spider-Man stopping a train? Okay, before that, I am going to show you the physical condition of the train now. Now there is a train. The train has a mass. It is running with the velocity of v. As a result of what does it have now? As the train moving with velocity of v and having a mass, what does it have? It has the kinetic energy. Yes, it has the kinetic energy. Ek of half mv square. Right. Now the engine, because of some failure, it doesn't apply with the brake. You can't apply the brake. It doesn't stop. The railway track is going to end within like few kilometers away. Now, what is the first thing he has to do? They have to stop the train somehow. What is the reason? So the train, if the train crashes, it will give like a very fatal result, like of the very recent accident took place in Kurunegala, like two days ago. It will be even chaotic. So he has to stop the train. That means he wants to bring this velocity to 0. There is the train, velocity is 0, mass is there, kinetic energy is 0. Then there is no problem. No harm. So you have to bring velocity to 0. How to bring velocity to 0? See the equation, E equals to half mv square. Mass is there, you are not destroying the mass. But you have to, if you want to bring this velocity to 0, what you have to do? You have to reduce kinetic energy gradually to 0, then velocity will automatically comes to 0. It was a bus from Polonnaru area. It passes our home usually at 1 p.m. Wow. You have to bring this stop by reducing kinetic energy to 0. Energy එක බිඳුවට බැස්සුවොත් අන්න velocity එකත් ඔටෝම බිඳුවට වහිනවා. Right. That is the condition we need to know. If you reduce the kinetic energy to 0, velocity also becomes 0. If Ek drops to 0, V drops to 0, 2. Now Spider-Man needs to stop all the kinetic energy. How he tried? Now tell me in the movie, in that clip I sent you, how he tried. මුලින්ම මොකද කරේ? හොඳට මතක් කරලා කියන්න. කට්ටියම ඉතින් ඩාටාක් ගාලා. නැත්තම් මේක කම්මැලි වෙනවා වැඩි. Elastic potential energy. No, that is not the first act he did. He just firstly stepped down and he came in front and held like this. He hit the sleepers. Sleepers කියන්නේ මෙන්න මේ කෝච්චි පාරේ මේව හරහට දාලා දිනවා ස්ලිපර් කොට කියලා කියන්නේ. These ones with his 2 feet like this, holding onto the train. What did you see? What did you see? After he was just hitting on this. Tell me. The planks got broke, sleepers got break, and also they just went everywhere here and there. ඒවා ගැලවි ගැලවි එහෙම ගියා. ඇත්තම කතන්දරේ ට්‍රේන් එක ඩීරේල් වෙනවා එතනින්ම. ඔබ ඇත්තටම කරන්න ඩීරේල් වෙලා කෝච් බාර කොහොමද එළියට පයින්. ස්ලීපර්ස් ටික නැති වෙච්ච ගමන් මෙහෙම දෙපැත්තට ඈත් වෙනවා වඩු වෙලා. It is just a movie. Then does happen. Okay. Somehow in that movie, so sleepers mean wood or something or concrete. Somehow it has chemical bonds. Everything is chemically bound in atoms. So these chemical bonds has to break. That means it has to spin to break the chemical bonds between atoms. Then some amount of the energy gone. Okay. Then you could realize when he does it, you could see some parts of his cloth got torn. That is also losing some energy. Okay. Then you could see there were like people in the train, they begin to scream. Then no, it has nothing to do with it because it is their own body energy they use. Okay. But there were some other sounds like when the glasses broke, that lose some energy. And you could see the train, the front part of the train got deformed. That loses energy. And it makes some sound of rattling. That also loses energy. Then you could see the road and rail track and wheels collide against and made some kind of a creaky sound. That also loses some energy in the form of sound. Then only he just throw his webs and the strings and he held like this. As you said, the elastic potential energy generated, as well as some parts of the buildings collapsed. That also loosened some energy. Finally, you could say between the rail track and the wheels, you could see something happen. There was a spark that produced light energy. Light energy in the form of light energy, sort of energy gone. Okay. So finally, it slammed against the last end of the railway track. It also used up some of energy. So this is how it completely converts its own kinetic energy to all the other forms of energy and stop the train. And one thing we can't feel in the system, that is heat energy. Because while these all processes take place, just rub your hands like this against each other. You can feel your palms getting warm. In the very cold time, we used to do like this and keep it like this to heat ourselves. It produces heat energy that we can't see. Now, can you understand? You can convert one form of energy to any other form of energy. Yes or no? Okay, understood? Enough. Now let's see how you have understood it. Before that, write a very big topic, huge topic, that is the law of conservation of energy. I think you listen to the longest explanation so far, because this lesson is that long, that deep. So that is why I wanted to give you the basic understanding somehow into your head. Then it is all okay. Now write the law of conservation of energy. The law of conservation of energy. Okay. Law of conservation of energy. Now write law of conservation of energy. Now start write the definition of that with the definition symbol. In an isolated system, I will tell you what is an isolated system, right? Just right. In an isolated system, the total energy in the system remaining constant, right? Remaining constant, right? Write this in a new line, to the same line. It doesn't matter. Since energy can never get destroyed or created. Get destroyed or created. Destroyed or created. It can only be, the energy can never be get destroyed or created. It can only be converted from one form to another. Okay. First of all, let me explain you what is an isolated system. Imagine like a bottle. You close everything. Right? Imagine no energy can come in. So this is a magical bottle. You enchanted with this one. Again, mantrayak කියලා තියෙන්නේ. No energy come in. No energy can go out. It is prevented. This is prevented. So energy inside this system can only interconvert, like potential to kinetic, kinetic to potential, kinetic to heat, electricity, light, like somehow all the energy interconvert and stay there. Imagine you just put like 100 joule with no specific variation. You are the god of this one. Now, after some time, you will see 20 joule light, 40 joule kinetic, 30 joule electrostatic. Yeah, and only 10 joule like heat. Another 10 minutes later, you also observe. You can see 30 joule heat, 10 joule kinetic, 25 joule light, and another like 35 joule electricity. Like it changed. but the total still be 100 joule. Understand? In an isolated system, it can only change. It doesn't create, it doesn't destroy, it will remain constant, but frequently it converts from one form to another, one form to another, one form to another. Understand? තිබිච්ච ටික මේ තියෙනවා මේ නෑ. Right? It had in one form, in the next minute it is not in that form, but it has converted to some other form. Can you understand it? Understand? Okay. Now if you want, this is an isolated system. In an isolated system, energy that does not flow in, energy does not go out. Okay. You introduce 100 joule. After 5 minutes, it is like this. After 10 minutes, it is like this. Conserve. Total is, what about T total here? 100 joule. Here, 100 joule. Understand? This is what called the total conservation of energy. Conserve. නැති වෙන්නෙත් නැහැ හැදෙන්නෙත් නැහැ. After 5 minutes, you observe like 102 now. Created. Another 5 minutes later, 98, 4 destroyed. එහෙම වෙන්නේ නැහැ. If now 100, 5 minutes again 100, again 100, 100, 100, 100, 100. You will learn something in university level called Gibbs free energy. They consider like the total energy in the universe supposed to be zero. පට්ට කතාවක් කියනවා Gibbs. Herschel Gibbs, he was a cricketer now, but this is a different Gibbs. Okay. Draw if you want. Okay. Now I want to check your understanding capacity. Let's see how you have understood. Now write down the type of energy conservation conversion. Write down the type of energy conversion occurring following occasions. You were wondering about what? You said like, I was wondering about it night before. What is it? Mark another wonder. About what? Energy does not create. Okay. By the way, I would just want to show you something. Now my class, for the paper class, it is fixed on Friday night. Okay, completely for permanently fixed on Friday night. So I want to show you my workbook. As I told you, I prepare a very professional type of workbook that you can never get from any tuition, other tuition class. I guarantee. So that workbook includes small question to very hard question in each topic. You have forgotten the past topics even. You will receive the part 2 of that like 2 months from here after discussion of this one. And everything you will receive accordingly. Okay. So in that one, I include one set of very complete paper. You might think, hey, Kai, to discuss that one, it will take more than 3 days. Complete physics paper we can't discuss within 1 day. Bad. පුළුවන්. නිකන් උඩින් කියාගෙන වලට තේරුනේ නැහැ ක්ලාස් එකේ හිටියා. කොහොම උඩුව වගේ ඉඳලා කරලා හරියන්නේ නැහැ. It is useless. We have to do properly, proper way. Hari. Then in the next workbook, the theoretical parts and the stuff will be very limited. It will only about circular motion, rotational motion, and hydrostatic and hydrodynamic. Very simple part. There will be 3 papers in that. After, I will give you the third book that is about waves. Let's go for the. I will show you the tube firstly. Banana tube එක. Can you see the tube? මේ පටන් ගන්න මෙතනින්. Including the homogeneity principle, see that you have forgotten a long time back. And it includes very hard questions in that. And motion, very simple question to hard questions and graphical questions and all. Then you have forgotten the shapes of graphs and all. I included some very important theory here that you do understand. Right? See? After that, I just had really hard graph questions, continue with graph questions, then the simple vertical projectile to very hard projectile questions. Then the force and motion, very simple questions I included. After that, I know you are really not comfortable with some of the force related questions. So I included some questions with initiative. See, ඔයාලට මුලින් ඉඳන්ම කරන්න ඕන කරන අර අමාරු කැලේ කොහොමද support කරන්නේ? How we support? And everything is there. Okay. See. මෙතන පටන් ගත්ත දැන ඉඳන් කොහොමද කරන්න යන්නේ කියලා support කරලා තියෙනවා. What equation you have to apply? Why you apply? How the forces are going to mark? Then see. Now the questions are turning to be really hard exam type of questions. See. These are exam type of questions. Then the momentum and the conservation of momentum and the angle part. See, there are very hard exam type of questions here. After that, mechanics in the equilibrium, we didn't discuss this deeper yet. I told you I am going to discuss those things in the paper class. මෙච්චර අමාරු දේවල් තාම කරේ නෑ. ඔයාලට නැචුව වෙන්න ඉඩ දීලා මම කරනවා කියන්නේ. Now it is time to do it. Can you see? Finally, it is about the energy conservation. Now going to do with like very big exam type of questions. See? Now there is the first paper. It consists of 50 MCQs. Really A-level standard. All the questions I got like from very reputed term tests and the government kind of like model papers and all, government model papers and all like really standard ones. It consists 50 MCQs. After that, structure question paper consisting for structures. Some experiments we didn't do in the theory class, and I'm going to explain you all the theory parts here and do it. හැමදේම cover කරනවා. මේක මම theory එකක් හැටියට කරන්න වෙලාවක් හම්බුනේ නැහැ class එකේ. I will demonstrate this as a practical and do it. See, very important questions and the projectile motion very hard ones. See, හිතා ගන්න බැරි තරම් සුපිරි එකක්. ඉතින් මම හිතනවා සිකුරාදා ඉඳන් හරියට වෙලාවට සෙට් වෙයි කියලා හැමෝම. Okay. Right. Have a good look at here now, Mike. I want you to tell me some answers that where I'm asking. So have a really good look at here. First thing is, you throw certain mass with initial velocity of u to a maximum height, final velocity of v. Okay, this is the starting condition. This is the finishing condition. Okay, that's the first one. Then you have like a certain inclined plane here. It is angled to theta. You keep certain mass here with an initial velocity of u. It reaches to here with unknown velocity. There v, it has the mass of m. This is the starting condition and this is the finishing condition. That is the second one. Now let me show you the third one. Now let me show you the third one. In the third one, there is a certain spring. That spring is compressed and attached to a certain block. Now you release the spring. You can see it as just compressed like distance of x. Once you release it, this mass begins to move with velocity. This is the starting condition. This is the final condition. Okay. And the last thing is, you throw an object on the ground with an initial velocity. It will slide down here and stop. V equal to 0. And there is a friction. And it will travel a distance of d. This is number 1. This is number 2. This is number 3. This is number 4. Now tell me, what are the changes of energy occur in each of these occasions? Occasion number 1, occasion number 2, occasion number 3, occasion number 4, separately. Tell me. Word by word. Huh? That's the best. Word by word කියලා ඉතින් එන අමාරු තේරුම් කරන්න. මවන්න වෙලා තියෙන්නේ. ඔළුවේ මවන්න වෙලා තියෙන්නේ. Kinetic energy is converted. Okay. Are you saying the answers? Okay. Very good. Your typing speed is unbelievably fast, man. What happened to people? Do they have very bad connection now? නමෝගෙම මේ යනවා එනවා join වෙනවා leave වෙනවා join වෙනවා leave වෙනවා. Joining and leaving. Might be having a very bad network, ne? I noticed Sanas was leaving 5 times and joining 5 times. Oh, now they just been left and joined. අද බෝයනේ කට්ටිය ගෙවල් වලින් නම් ෆිල්ම් බලනවා. ඒකයි. Network is very horribly traffic. Okay. හරි. කට්ටියම කියන්නකෝ මෙන්න තීරුවේ මොකක්ද වෙන්නේ කියලා ඔබට. Okay, Ramai. I think we had enough time. What about the first one? What about the first one? In the first one, you can see, Lamai, it is converting from kinetic energy. At the beginning, it had kinetic energy. Yes. Finally, it reached to potential energy. It converted from kinetic energy to potential energy. That is the conversion occurred. Okay, you understand? Yeah. Okay, you understand it? It had kinetic energy here. Now it reached to potential energy. That's how the energy conversion took place. Now here, how about here? Can you see? Here it had, because of the height, it had potential energy. Now the potential energy converted to kinetic energy. It earlier had potential energy. Now it converted to kinetic energy. Okay, gravitational, you have to mention the word GPE. That's enough. GPE is enough. Gravitational potential energy. Here, see. Now it is restricted with the spring and you release. Spring releases it. What is it? Huh? What is it? See. Elastic potential energy you release and it projected with velocity v. That is the mechanism we use in catapult. We just pull the stuff and release and the bow and all. Elastic potential energy you release and it converts to kinetic energy, then elastic potential energy to kinetic energy. That is how it converts. Okay. Right. Here, this part, it had kinetic energy. After it will just run through the surface. It is something like this. See, you throw, it stops. You throw, it stops. Throw, it stops. Why? Initially, it had kinetic energy. After running through this one, it loses kinetic energy, all because of it has to do a work against friction. We don't say like a frictional energy, there is no energy exists like that. But we say like, here it has the potential kinetic energy, finally it reaches to here and loses up energy in the form of work done against friction. It is what? Kinetic energy. This is what? Work done against friction. That's all. හරි නේද? හතරම තේරුණානේ. ඕහ යේ කියන්න. ඕනේ? Ah, yes. Okay. Now, I am going to test your basic understanding. Let's check. Let's check. Right. Now I'm going to put all of these with numerical values. All of these with numerical values. Here it is like 30 ms minus 1. 30 ms minus 1. It's reached to 0. Here like 5 meters. And here the angle is 30 degrees. Okay, you need to find out velocity here. Here you have to find out height here. Here I will give you like the constant like 200 newtons per meter. And the mass here is like 4 kilogram. And the extension is 20 centimeter. 20 centimeter. Okay. Now in this part, mu is 0.4. And initial velocity is 20 meters per second. What I need is distance. You need to find out distance. Mu. Right. You got all these info with you. Just find relevant for answers here. For the first one, height. Just find height. If I tell you that, I will tell the answer. That is there because of some reason. Just check. Just check. That's because of some reason. I do whatever with the reason. Got it? Very good girl. Tejaswin boy, try it, my dear. Okay, take your time. Take your time. Yeah, Tejaswin, very good boy. I asked you to do everything. All four, not only one. Please. Okay, do it fast. අතරම කරන්න පොඩි ප්‍රශ්න මගේ පන්තියේ ළමයින්ට පොඩි ප්‍රශ්න ඕන. මොකද තියරි එක පොවලා තියෙන්නේ දැන්. පුළුවන් නම් මම දාන වර්ක්ෂීට් එක යාළුවන්ට දාලා බලන්න එක එකට කරන්න බෑ. ඊගම නම් තඩි වීලු කාර්ය සෙට් එකක් ඉඳලා සෙට් එක එකට දිවත් ළමයින්ට කරන්න බෑ මම දාන වර්ක්ෂීට් එක. try කරන්න. හරි කරමු. Do it. හා හරිද? නේද? ඔතේ ළමයි නේද? Shall I start to discuss? Or do you need time? Do you need time? Or shall I start discussing? Yeah, Vidusana, good girl. Tejaswin, good boy. Pehan, good boy. Fatima Sanas, after a very long time. What do you reckon? Shall I start discussion? Let's start discussion. Okay. For the first one, you have to draw separate diagrams, not the previous diagrams. මම ඒකේ අnder ඔයාලා අලුතෙන් අඳින්න ඕනේ. කම්මැලි වෙන්න එපා. Here, in the traditional method, how can we do? We can use what? Motion equation. The first question we can do in both ways easily. V square equals to U square plus 2AS. You might argue with me. So the equation is very easy to use it. Why are we learning that? You will learn within 1 minute. V0 U is like 30 square minus 2 times 10 times H. 20H equals to like 900. H is equals to 900 over 20. So it is 45 meter. Wow. Excellent and fantastic. That's how you may think. You can get the same answer in another way. How? You know one thing. According to law of conservation of energy, a law Coy, you have to mention that because that is where you get the mark. Then the paper marking dude will understand he or she knows how to apply physics concepts really well. That is the impression they gain. So thanks to that, according to the law of conservation of energy, a law called, have a look at half mv square equals to mgh. Here, m and m cancel off. This way, Vidusana, you asked me. So you haven't given me a mass. When I said, if I said the condition is going to violate, then you understood within 25 seconds. That is very good. H equals to v square over 2g. See, let's see. V is going to be 30 times 30, 2 times 10. It is like 90 divided by 2 is 45 meter. You get the same answer. You may see both the methods are the same. I also agree with you. In both cases, you can apply this or this. No change. Copy this one. May become okay. But within 1 minute, you will learn this wrong here. Copy this quickly. It has certain specific process for you to do. I will erase. Enough time I have given. Now, in this case also, I want to do in traditional method. See how will it take. You have to find out initial velocity is 0. Okay, final velocity I don't know. Firstly, I have to find out acceleration. So the force is like mg sine theta, sine 30. Okay, what can I do is F equals to ma. F is mg sine 30 equals to ma. M and m cancel off. A equals to g sine 30. So A is equals to 10 times half. That is equals to 5 ms minus 2. I found it because my equation is going to be v square equals u square plus 2as. I have to find out acceleration. I found it. Then I have to find out displacement. See? Oh my God. How to find out that? Now you have to use this triangle laws, trigonometry, 30 degree, 5, this displacement s. Okay, what is this side? Opposite side, hypotenuse or sine theta. 5 over s equals to sine 30. S equals to 5 over sine 30. 5 divided by half. It is 10 meter. Oh my God. Now you can say like this boy is oh my mind kila. Moketada? Mardiga ini. Epa nani? මේ ක්‍රමේ හරියන්නේ නැහැ. Have a good look. Now you found. Now you can apply. V square equals to u is 0, no problem. 2 times, 5 times, 10. V square equals to 100. V is equals to root 10, 100. V equals to 10 ms minus 1. In traditional method, make extra set ne. It is a very long process. It's a very long process. So copy it. Then I will tell you the easy process. It is like pasteurization process. Okay, Raman. Weekly. Comedy ka dagan. Okay, quickly. Shall I erase? Mang kalian lah yang addition. In my other process, I don't need any of these. मैं किसी देर कौन? I only need here it has potential energy, okay, here it has kinetic energy. That is the only thing I need. Okay. If E equals to AK, according to what? According to law of conservation of energy. In the previous one, alloc here it is like alloc. It took me some time to realize what a mistake I tried to do. In second one, since I tried to do in the usual method, suddenly I stuck me law of conservation of energy. At least you realize after some time. That is great. Still great. But E plus mgh here, that's equals to half mv square. M and M cancel off. You just need to subject V here. When you cross multiply this out, it is going to be 2gh is V square. V is going to be root 2gh. Now have a really good look at V equals to square root of 2 times G is 10 times height is 5. Finance is 2, it's like 10 times 10. V is going to be the square root of 100. V is just 10 ms minus 1. Now tell me which method is suitable for the second one. Which method is suitable for the second one? First method, traditional method, or energy method? Hello, koi. Yes. Hello, koi. Hello, koi. Haha. Hello, koi, man. Hello, koi. මම ඔයාලව තව මාස දෙකකට පස්සේ රෙඩි කරනවා ලංකාවේ ඕනම එකෙක් ටියුෂන් ක්ලාස් එකක පේපර් එකක පාස් පේපර් එකක තියෙන ඕනම ප්‍රශ්නයක් ගේමක් නැතුව හදලා ගන්න. දැන්ටමත් ඔයාලා ලෙවල් එකේ තමයි ඉන්නේ. වර්ක් බුක් එක කරපු ගමන් වැඩේ ගොඩාක් මේ පේනවනේ. දන්නවනේ සර් රාමෙන් දෙන්නේ පළවෙනි මාසේ දෙනවා ලස්සනට යුට් එක. ඊට පස්සේ මුකුත්ම නැහැ නේ. මගේ අන්තිමට මේ 2025 දැන් තව මාස 6කින් යන්න ඉන්න උන් ටික මේ. උන්ටත් දෙන්නේ පට්ට කොලිටි එක. මං කියවනේ උන් තමයි මගේ අංක එක. සාමාන්‍යයෙන් අනිත් පැත්තට සලකන්නේ මුලට හොඳට සලකනවා අගට සලකන්නේ. මගේ වනේ අන්තිමට ඉන්න උන්ට තමයි හොඳටම සලකන්නේ. උන්ගේ රිසල්ට් එක ගන්න එක තමයි මොකද අවුරුදු දෙකක් තුනක් මං ගැන විශ්වාස කරලා ඉඳපු නේ. හරි. ඔයාලා තව මාස දෙකකින් මෙකැනික්ස් වල කිව්වා. දැන්වත් එහෙම. හරි. මේ ටික හරිනේ. අන්තිමේකට යන්න. Let's move to the last one. In the last one, dear students, have a good look at. It has the potential kinetic energy at the beginning. Okay. At the end, work done. Velocity is 0. Total kinetic energy is gone. It has not destroyed. It has only converted to another form. Half mv square equals to, what is the work done? Work done against frictional force times distance. What is friction? Mu mg d. Okay, have a look at how mv square equals to mu mg times d. M and n cancel off. You need to find out d. D is what? V square over 2 mu g. In the previous one, could you remember? Here, what is it? V is what? We got like V is equals to, sorry, S equals to V square over 2g. Here, the same thing, only mu included. V is like 20. 20 multiplied by 20 divided by 2 times 5. Pi is, sorry, mu is 0.4. 2 gone. 4 times 0.4 times 10 is 4. Answer is just 5 meters. Wow. හරි අමාරුයිනේ ඒක. ඈ? ඒක වට අමාරුයිනේ ඇත්තද? එහෙමද නෑනේ. ගේමක් නෑනේ. ළමයි අඳුරු පෙරාගෙන ළමයි යන්න පාඩම මේක. ඔයාලා කාට අන්නන්න සිද්ධ වුනේ? I'm pretty sure all of you understood it very, very perfectly well. Emane? Say. Yes, me? Say yes. No, it is 5. Wait. Yeah, wait. It is 50, Lamai. It is my mistake. It is 50. There is a 0 here. I forgot. Good observation. It is 50 meter. Very good. Good observation. It is 50 meter. It is my mistake. 50 meter, Lamai. අමාරුම ටික ඉවරයි. Next week එකේ questions, A level questions, everything. In the very next week, according to your request, we can extend 1 week for questions or directly start the circular motion part. හරි? එක්කෝ කරනවා නැත්නම් circular motion. කැමැත්තක් කරන්න. Do whatever you want. Hane? If you want, we can start circular motion. අපි බලමු ලබන සතියේ කරලා මේක සෙට් නම් අවුලක් නැහැ. සෙට් මදි වගේ නම් තව සතියක් කරන්න වෙයි. ඒක ඉතින් ඔයාලගේ කන්ඩිෂන් එක. මම නම් හරි ආසයි හෙට හරි circular motion පටන් ගන්න මේක ඉරක් කරලා දාන්න. Okay? එච්චරයි. ඇති. Hungry? Interval? Just 10 minutes, 12 minutes, 15 minutes. ටක් ගාලා කියන්න. කොච්චරක් ඕනද interval? 10, 12, 15. ටක් ගාලා කියන්න. වැඩිම ඉල්ලුමට දෙනවා. Anything for me, it doesn't matter. 12 minutes, okay? Going back around interval. Join back. Around 10:06.